Well, hello and welcome YouTube. Mr. Robinson back here with yet another brand new exciting video, all math-based of course, and as always, it is an honor and a privilege to be serving you here today, as it is every day here in my virtual classroom. Step on inside as we jump into the sections 4.1, 4.2, and 4.3 quiz in the Big Ideas Math Integrated Math 1 textbook, writing equations in slope-intercept form, point-slope form, and writing equations of parallel and perpendicular lines. 16 questions in total. I'll try and rummage through the formulas again as you need to, and whatever kinds of problems we have. Graph paper will be provided in the description section down below as a PDF, as well as the actual PDF for the single page that you have. If you'd like to follow along with any of that, please download those. And, of course, timestamps down below for each individual problem. Without further ado, I'm going to go ahead and get started. We have numbers 1, 2, and 3 where they say write an equation of the line in slope-intercept form. Now, because these ones are graphed, I prefer to use the graph to actually come up with the slope itself, because there are two things that I'm going to need. One of them I'll be using the graph for sure is the y-intercept. Not just where it crosses the y-axis, but the value of y where x equals 0, which means we could do this without the graph. The y-intercept is going to be the b value, -2. By the way, this is for y equals mx plus b form. The b value is -2. The m is all about this rise over this run. How much do we go up? How much do we go over? In this case, positive slope is up and to the right. We go up 1, 2, 3, 4, 5. That's the distance from -2 to 3. And the distance from 0 to 1 is a run of 1. So your slope is 5 over 1, also written as 5. You can kind of do one or the other. I kind of prefer the integer, of course. So that equation is going to be y equals 5x minus 2. This is your y equals mx plus b form. There you have it. Number 2. Sorry, I'm trying to look at all the different problems. Okay, because of number 7, 8, and 9 not having graphs there that I can use slope-intercept form for that, I'm going to not calculate slopes here. I will only count them. So number 2. Sorry, I got to copy-paste these guys. I got this line right here. Now, this one goes down as it goes to the right. That is actually indicative of a negative slope. So that's what we're dealing with here, a negative slope. And one way you can tell is as you go to right, like I said, we're going to the right 3, but we're going down 1. So that 1 will be negative. So this slope, again, it's a rise over run or fall over run, this time of -1/3. The b value is the y-intercept, and that is going to be 5, the value of y when x equals 0. So those two numbers together give us y equals -1/3 x plus 5. And all of these are asking in slope-intercept form. That means they have to give you the y-intercept at some, well, they don't have to. But based on the section, they were giving you the y-intercept in that stage. Otherwise, we have different forms that we can use or different processes in how to get there. But these ones straight up, we're trying to pull out the information. Now, number 3, we have one that's crossing through the origin, 0, 0. As far as the b value goes, that's going to be 0. The slope is also negative. We're going down 4, right, 2. The slope is -4 over 2. We must reduce this to at least -2 over 1. I'm going to write -2 personally. So this can be written as y equals negative, let me do kind of the raw version, -2 over 1x plus 0. Not a fan of that in general. If you look at any answer key, you're probably going to see this. Y equals -2x. Notice anything added with 0 is just, that's something. So y equals -2x can just be the version of that equation there. Okay, let's go to numbers 4 through 6. Write an equation in point-slope form of the line that passes through the given points. Now, remember, slope-intercept form used the y-intercept in all 3 of those. Even if you didn't have the graph, you could find the value, you would use the value of y when x equaled 0. None of these have the value of y when x equals 0, so slope-intercept form is a little bit more difficult to come by for a problem like that. Point-slope form is a lot better for this appearance because there's no extra work you have to do once you plug in your desired points you need for your form. Speaking of which, what does this formula look like? Point-slope form looks like y minus y1 equals m times x minus x1, x sub 1, y sub 1, x sub 1. The point that we cross through is your x1, y1. You can either choose this point or this point for it to work. Your m is your slope. We don't have the slope in this set, so we got to find it. Even if you were like, I want to use slope-intercept form, you still got to find the slope. Now, we were doing slopes before by counting rise over run. This time, let's start doing slope by using its formula, y2 minus y1 over x2 minus x1. Subtract one y from the other, subtract one x from the other. So I can do here, the slope is the change in y, y2 minus y1, over x2 minus x1, like so. Negative 1 minus 5 is negative 6. 1 minus negative 2 is 1 plus 2, which is 3. This leaves you with a slope of negative 2. So this is our m that'll go into here, right? M. As far as x1, y1, we have a choice. For example, I could write this as an answer for my y1. I can write 5. For my x1, I can write negative 2. And I can write the form y minus 5 equals slope m times x minus negative 2. We just saw what happens when you subtract a negative. It becomes addition. So x plus 2. Here's a version of the answer that is acceptable. This works. Or you can use these 2 points as your x1, y1 values, and they will represent the same exact line. So you can also do y minus negative 1, that's y plus 1, equals same slope times x minus 1. The x minus x1 right there. Both of these are solutions, or well, are representations of the line, because both these points are solutions, points on the line. And so they both work. These aren't slope-intercept form, it's point-slope form. Note, if I did get these in a slope-intercept form, I'd get the exact same value. What is it? I don't know. They didn't ask. I'm not going to do it. I'm moving on to number 5. Problem number 5, same set, same idea. Let's just move on to the next page here. So problem number 5, let's find the slope. The rise over run or the fall over run from one point to the next. A lot of negatives involved. So if you try to do slope mentally, just be careful. I'm going to not for this one here. Let's do negative 1 minus negative 2 over 2 minus negative 3. 2 minus negative 3 is 2 plus 3. That's 5. Negative 1 minus negative 2 is negative 1 plus 2, which is 2 minus 1, which is 1. Oh my gosh, that was a breathful. So I have a slope here, and I have either set of points I can choose here. Once again, if I choose this set as my x1, y1 as the formula, I got y plus 2 equals 1/5 times x plus 3. If you notice, once again, because we haven't really graphed out a point slope form, there was one problem that I got to do it out of from section 4.2. It was a problem where they kind of let me. Outside of that, yeah. So if you have these equations, notice these are opposite of what the signs are going to be. X plus 3, the x value is negative 3. Y plus 2, the y value is negative 2. Okay? This will be y plus 1 equals m times x minus x1, like that, x minus 2 like that. This is one or the other, right? That's what I'm writing here. Either or is acceptable. You don't have to write both. You don't have to write both. Next one has 1, 0, and 4, 4. I think these ones are a little better off as far as mental work goes in getting that slope. Let's see if we can try this together. How much are we rising from 0 to 4? How much are we running from 1 to 4? From 0 to 4 is a rise of 4. From 1 to 4 is a rise of 3. Your slope is 4/3. This can be your x1, y1. Now, if your y1 is 0, what is y minus 0 the same as? Just y. So equals m, here's your slope, times the quantity x minus x1. So x minus 1 like that. Here's an answer. Or y minus 4 equals 4/3 times x minus 4. Quantity x minus 4. Like so. One or the other, again, same result. Now, we haven't run into anything yet with a 0 slope or an undefined slope. I just want to remind you, if you had the same two y values of 2, if this was negative 2 and this was negative 2, then you have no rise as you run somewhere. That will have a slope of 0. Horizontal lines have a slope of 0. If your x's were the same, negative 3 and negative 3, for example, that's all rise and no run. That means it's a vertical line with an undefined slope. Those you can't write in any of these forms. The slope of 0 you can. We might run into them, but so far we haven't, so I'm actually, now that I'm looking at number 8, maybe we will. Okay, anyway, it says write a linear function f with the given values. Numbers 7, 8, 9, but number 7 specifically gives me f of 0 of 2 and f of 5 equals negative 3. Sorry, f of 0 equals 2 and f of 5 equals negative 3. 0 is an input, 2 is an output. That means that's an x comma y. I've tried to do it without writing these points. It's kind of hard for me to do it without writing them. So 0, 2 is a point, 5 is an input, negative 3 is an output. There's another x, y. So they said write an equation here. Yeah? So what we're going to do is come up with the slope and y-intercept, or slope and write it in point slope form. Actually, it says write a linear function f, so we do want slope-intercept form. So here's the thing. I'm going to start with the slope. Now, my rise, see, I'm running from 0 to 5. That is a run of 5. And I'm going from 2 to negative 3. 2 minus what is negative 3? That's negative 5. So I'm trying that one in my head just for this problem. unless the other ones are easy. So the slope of -1. Now here's the thing, guys. This is a b value. B is 2. B is 2. This is your y-intercept, the value of y1x equals 0. Save yourself time if you're able to write it that way. This is using function notation, and I know in the sections 4.1 or 4.2 or whatever, I sometimes forgot and just wrote y equals. For these 3 problems, I want to be able to write f of x and not mess up. So instead of y equals mx plus b, I'm writing f of x equals mx plus b. Actually, let's do this. Before I'm going to write y equals, and here's my slope, -1x plus y-intercept is 2. -1 times x is also -x. So here's where I'm going to write the final result of that guy there. So that should be your final answer. Number 8 has f of -1 equals -6 and f of 4 equals -6. This time you don't have the luxury of a y-intercept because none of these are inputs of 0. That's -1, -6. And then this guy's f of 4 equals -6. But this does have a different luxury. And that luxury is your slope being 0. I was going to say -6, and I'm like, I don't want to say that. Your slope being 0. From this x to this x, there's a run of how much, who cares, as long as it's more than 1. It's 5, I suppose, but the y doesn't change. Your slope is 0 over 5, I guess? Okay, well, that's 0. So when you have a 0 slope, again, this is one of those things where you can write y equals mx plus b. You know, as we get deeper into this thing, I really want to make sure you understand that a slope of 0 means the y value is never going to change. This is -6, this is -6. When x is 0, it's going to be -6. It has to be. Therefore, your equation is y equals -6. It's f of x equals -6. That's just the equation. It's a constant function. Not really a linear function, but a constant function. And I'll leave that one at that, right? These are ones where I want to show you based on the nature of the problem. If you want to see me actually plug values in until I get that one out, okay. I'm not going to right now, but that's an option. I'll spend some time on this problem if you'd like me to. That'll work out. So this one has no level of uniqueness like the other problems do, no special cases. I got a -3, -2, and a -2, 3. So besides the fact that the numbers are kind of close to each other, but are they really? Your rise here is a 3 minus -2. Your run here is a -2 minus -3. -2 plus 3 is 1 on the bottom. On top, you have 3 plus 2, which is 5. So we got a slope of 5. Okay, I'm going to do this in 3 different ways. And you're going to see I'm going to get the same answer each time. We're going to write this in slope-intercept form, but I'm going to start with point-slope form. So version number 1 is use these 2 points here. Y minus y1 equals m times x minus x1. Let's get y by itself, and we will get, with a simplified version here, if I subtract 2 from both sides, we'll get y equals 5x plus 13. Here's a way we can get that answer. I will write function notation at the end, but there's that. Option number 2, use these 2 points. I got y minus y1 equals m times x minus x1. If I distribute the 5 this time, I get y minus 3 equals 5x plus 10. And now I add 3 to both sides, and 10 plus 3 is still 13. So I still get the same answer there. A third option, and we actually learned this in section 4.3, so I'm jumping the gun a little bit, but it's still something I want you to make sure you know. We can start in slope-intercept form and still get the answer, as in currently with only knowing the slope of 5 and not knowing my y-intercept, my equation is some form of y equals 5x plus b, right? I mean, of course, these answers have a 5 as well. How do you get the b value? You can substitute, and I'm not going to do this part twice, but you can either substitute -3, -2 for x and y, or -2 and 3 for x and y, and you should get that value of 13. I'm only going to do it once this time. I hope you don't mind, but I'm only going to plug in, like, say, -2, 3 here. So 3 equals 5 times -2 plus b. Gets you 3 equals -10 plus b. Add 10 to both sides. And that gets you a b value of 13. So your equation is y equals 5x plus 13. Now, I showed it to you twice in point-slope form so that you trusted that either point-slope form will get you that same y-intercept. Plugging this in is not a form. Plugging this in is meant to get you a b value so you can write it in your form. That's the difference, and that's why I'm not starting that one up. But no matter what, you get y equals 5x plus 13, so my final equation is f of x equals 5x plus 13. kind of your choice on how you go about it. Because the section that we were based off of, you probably should be using point slope form for either one. Okay, numbers 10 and 11, determine which lines, if any, are parallel or perpendicular. Explain. This was out of section 4.3, parallel and perpendicular lines. On number 10, we actually have points for which we need to, so A has -2, 2, and 2, 1. And we have to find its slope. If we find out that the slope is the same as the slope of another line, that means they're parallel. And if they're opposite reciprocal slopes, that means they're perpendicular. I'm going to go kind of quicker on my slope calculations, though. From 2 to 1 is a fall of 1. From -2 to +2 is a run of 4. So that's the slope of line A. On line B, we go from 1, -8 to 3, 0. So from 1 to 3 on X, that's your run. Your run is 2. From -8 to 0, that is a climb. That is an ascent. We are rising 8, and 8 over 2 is 4. So we have -1/4 here, 4 here. These aren't answers, by the way. This is just us getting to slopes to compare. Line C has points -4, -3, and 0, 2. 0, -2, excuse me. From -4 to 0 is a run of 4. From -3 to -2 is a rise of 1. So that's 1/4. So let's compare these. Are any of them the same? No. That's a -1/4. That's a +1/4. And I'm assuming that I actually didn't mess up here. And that's a 4 here. So none of these are the same. Therefore, nothing is parallel. They're asking to determine which any are parallel or perpendicular. Are any perpendicular? We need opposite reciprocal slopes. Opposite means a sign change, such as from this negative to this positive or this negative to this positive. So these can't be perpendicular because they're not opposite signs. But these may be, or these may be. We also need reciprocal, as in a flip of a fraction. Now, 4 is also 4 over 1. So this is a flip of this one and a flip of this one. But because these are the same sign, these are just reciprocals. Because these are the same fraction, these are just opposites. But opposite reciprocals are A and B. These are opposite reciprocals of each other. The book says negative reciprocals. Therefore, they are perpendicular. Lines A and B are perpendicular. None are parallel, but that is our final conclusion. So comparing slopes, that's what we got. Okay, number 11 does not show points, but they show equations. Now, because it's all about slope comparison, we're still checking for same slope, opposite reciprocal slope, things like that. But when it comes down to it, we have to do it based off of getting into slope-intercept form. Currently, this is in standard form. 2 is not my slope. Again, 2 is not my slope. This isn't y equals mx plus b yet. Let's get y all by itself by subtracting 2x from both sides. And then dividing everything here by 6. And this will get me, make sure you reduce your fraction, -1/3 x plus 2. The slope of line A is -1/3. Ma equals -1/3. The slope of line B, well, this equation's already in slope-intercept form. Y equals 3/2 x minus 5. So the slope of line B is 3/2. Again, it's not the x, but equals 3/2. These are not the same. These are not opposite reciprocals. These are neither parallel nor perpendicular to each other. Let's see if C is parallel or perpendicular to either A or B. C is also in standard form. Let's subtract 3x from both sides. And then everything's negative. That's kind of scary, but we're going to divide by a negative here. We divide everything by -2, which turns everything positive. Everything turns positive. And this becomes y equals positive 3/2 x plus 2. Right now, the y-intercepts haven't really meant much of anything unless the y-intercept showed that you are the exact same line as another line, which has happened. I've seen that. But we have that. Okay, 3/2 here, 3/2 for B, and -1/3 for A. So A is the one that stands out as different. Not in a good way. It's not perpendicular. But B and C appear to be parallel to each other because of their same slopes. So lines B and C, not perpendicular, but are parallel. And that's some of what section 4.3 has to offer. Okay. Let's go to 12, 13, and 14. Still more of section 4.3. Write an equation of the line that passes through the given point and is either parallel or perpendicular to the given. Well, not either or. We're going to do both. So we have 3 problems to do these with. So on number 12, let's get that graph on. We have a line which the points are not like displayed. We have to come up with some points that are on here. So we have a line right there, and we have to say, I need to go parallel to this line and make an equation. I need to go perpendicular to this line and make an equation. So let's find out 2 points on this line so we can determine its slope. From here to here, I rise 3, I run 1. The slope of this line is 3. That means the opposite reciprocal slope, the perpendicular one, is negative 1/3. Now, both of these can be used for us to end up writing an equation of either line, the parallel and the perpendicular. We have this x and y that we can substitute into our equation to find that. Remember our y equals mx plus b? For the parallel, it's y equals 3x plus b plus some b, which we have to figure out. Hold on. And for the perpendicular, it's y equals negative 1/3 x plus some b, like that. So if I substitute 2 for y and 6 for x, I get 2 equals 3 times 6 plus b, or 2 equals 18 plus b, or when I subtract 18 from both sides, I get b equals negative 16. So my equation for the parallel one is going to be y equals 3x minus 16. That's the parallel line. The perpendicular line, I still substitute the 2 and the 6 in here. I got to take negative 1/3 of 6. That's like taking 1/3 of 6 and making it negative. So negative 2 plus b. And when I add 2 to both sides here, I get a b value of 4. So this equation will be, for perpendicular, mind you, perpendicular, I'll just put perp. Y equals negative 1/3 x plus 4. So that's how I use slope-intercept form on both of those as a method to get slope-intercept form as answers. Okay, there's the A, there's the B. Okay, now this time I'll do them completely separate. Now that I see that they are parts A and B, I think we'll keep it a lot cleaner that way. So number 13, we have to go parallel and perpendicular to this line here, right here. And I'm looking at, I'm going to put it over here. I'm looking at a slope of this one of down 1 and right 2, negative 1, right 2. So the original slope is negative 1/2. The opposite reciprocal slope, flip that to 2 over 1 and make it positive, so 2. So part A, let's do parallel. We have, what point? We're going through the point, here it is. We're going through the point negative 2, negative 3. So I'm going to substitute negative 3 for y. We have the negative 1/2 here, times negative 2 for x plus b. Negative 3 is, that's a 1 plus b, and subtract 1, we get a b value of negative 4. Remember what we're doing with this, though, as well, right? We're going to write a new y equals mx plus b equation. Y equals m, x plus b, minus 4. For part B, on perpendicular, or perp, we have negative 3 again equals negative 1/2 times, excuse me, not negative 1/2, now it's 2. 2 times negative 2 plus b, that's negative 8, and that's negative 3, and we add 8 to both sides, and we get a b value of 5. So this will be the equation y equals positive, I keep forgetting, positive 2x plus 5. Oh, sorry, I substituted negative 4. What did I do right here? Let me do this again. That's a negative 2. My bad. Negative 2. You know what I was thinking? Multiplying them to get negative 4. I was really thinking ahead on the problem, and that happened. So we're going to add 4. We're going to add 4, and that's a b value of 1, so 2x plus 1. Now, I probably could have looked at this graph and done a double check on that to see what would make most sense. If this is a slope of 2, up 2 over 1, up 2 over 1, look, it does cross at 1. It doesn't cross at 5, so there's the perpendicular one like that. Okay, the last one on number 14. This time, I'm actually going to use point-slope form. I'll get it in slope-intercept form, but I'm going to give you a different, kind of back to that other version, just so we're practicing everything under the sun. So on number 14, point slope form will be fine. We have the y value of 0. First, slope-wise, we're going down 1, 2, 3, 4, and right 1. So the original slope is -4. So the opposite reciprocal perpendicular slope is 1/4. Okay. Let's do part A on parallel. Okay, parallel. I'll put the parallel symbol. Whoop. Okay. Y minus y1, which is y minus 0. That's just y. I'm going to write it anyway. Y minus 0 equals m times x minus x1 minus -4 is plus 4. Y minus 0 is y. -4 distributes into here. You get -4x minus 16. That's actually it. On part B, again, y minus 0 equals, now this time it's a positive 1/4, times x plus 4. And then we distribute this one here, and this is going to be y equals 1/4 x plus 1. So again, what I was doing in these cases here was I used point slope form. It was a very clean version of it just because the y minus 0. And yeah, that's it. I actually felt faster, right? Okay, 2 more questions as a whole. We have numbers 15 and 16. On number 15, it says, a website hosting company charges an initial fee of $48 to set up a website. The company charges $44 per month to maintain the website. It's out of section 4.1, and it sure sounds like it. They have kind of a slope-intercept form setup, initial value, and a rate. It says, write a linear model that represents the total cost of setting up and maintaining a website as a function of the number of months it is maintained. I'm going to write this in function notation. I'm going to write C of m. C is cost, m is number of months. Now I have a rate of $44 per month. That is 44 times, or, that's the rate, times the number of months gives you that. So y equals mx plus b, initial fee of $48, your y-intercept. That's part A. Part B, find the total cost of setting up a website and maintaining it for 6 months. I want to do C of 6, so we're going to take 44 times 6 plus 48. 44 times 6 is 264 plus 48 is 312? $312. Substitution, calculation, evaluation. Yeah, I already know what it is. Part C says a different website hosting company charges $62 per month to maintain a website, but there is no initial setup fee, and you have $620. At which company can you set up and maintain a website for the greatest amount of time? Explain. Let's first start with this company here still. We have C of M equals $620. Now we're going to substitute 620 and solve for how many months it will take. Like basically how many months I can get out of it. If I subtract 48 from both sides, I will get over here 572. Is that M equals 13? 40, 44, 5. Yeah, I think it's 13. M equals 13 months. So we got 13 months out of that guy. Okay, now the other one, I'm just going to make an X thing in it. They said there's no initial setup fee, so I have another one that's like 62X equals 620. And divide that by 62. That'll be X equals 10. You know what? I should say M still. M. 62 times M is 620. So that is M equals 10 months. So in comparison, you get much more bang for your buck with the $620. Greatest amount of time is the first equation, original equation. What are they? Companies, website hosting company. The original website company. You get 3 extra months out of your $620. 13 months versus 10 months. Whoa, I wanted to box that. All right, I have one more question, and it's number 16. Guess we won't make the half-hour mark, but still pretty good regardless. Number 16, the table shows the amount of water remaining in a water tank as it drains. Can the situation be modeled by a linear equation? I'm going to guess so, otherwise it would be kind of a bad quiz question to do. Just because we're... Bad review question. Nope, moving on. Nope, we're done. Take care, guys. I haven't checked it yet, though. Explain if possible. Explain. If possible, write a linear model that represents the amount of water remaining in the tank as a function of time, which means slope-intercept forms kind of our end goal here. What we got to see is, do we have a constant rate of change on x and y simultaneously? We're adding 2 to x, 2 minutes, each time here, and we're losing 5 gallons of water each time. This makes this linear. My explanation is C over there. So linear, constant rate of change. Okay. So we're going to write a function. In order to do this, we need some sort of slope. The slope's given to you, or you're working out slope right now. You're subtracting 5 each time you increase by 2. Your slope is negative 5 over 2. Down 5 gallons of water every 2 minutes. And this is in the tank is draining like that. So negative 5 over 2. Now we don't have a y-intercept. So what I want to do is just choose some points. I'm going to choose the kind of cleanest looking points that I have here, these ones. And I'm going to go ahead and use point slope form for this one. So y minus y1 equals m times x minus x1. If I distribute the negative 5 over 2, negative 5 over 2 times negative 10 is 10 divided by 2 is 5, times 5 is 25, and it's positive. And if I add 150 over, then I will get y equals negative 5 halves x plus 175. You can also, of course, do this using the slope-intercept form method to get there. And of course, if this was water and this was time, I can do something like a function notation one. They said water is a function of time. How about w of t equals negative 5 halves t plus 175? That one looks pretty good. Do they want us to do anything with it? Doesn't look like it. Now, listen, I chose this set of points. You had 5 different sets of points to choose from. You also had any 2 sets of points that you wanted to choose to get the slope. Because I wrote this like this right here, your slope was clearly defined. I don't have to write this again, this minus this over that minus that. So all that's taken care of, guys, and that's it. And I don't think we didn't draw any graphs per se, right? So I don't have to attach any. Guys, that'll do it for this one. This is Mr. Robinson. Thank you so much for watching. The next part of the chapter is going to deal more with some statistics things and plus something called arithmetic sequences. So we're going to take some of what we know how to do and use it for that stuff, but we're going to learn some things on a statistical basis-ish. Scatter plots. Take care, guys. I'm going to see you in that next one.